Okay, so this is number 4H, and what we have to find is f composed of g of x and g composed of f of x, and state the domain of each. So first we'll do f composed of g of x. So there we go. F composed of g of x. Okay, so we're plugging g of x for whenever we see an x in f. So f of x equals the absolute value of x minus 2, close absolute value, minus 3. So first we'll do the absolute value of, now we're going to plug in 1 over x for x, minus 2, minus 3. Okay, and now we can simplify that and make x the denominator. And if we do that, that means we have to add an x to negative 2. So it becomes 1 minus 2x minus 3. Now the domain of that domain is x cannot equal 0 because we cannot divide by 0 or else the number will be undefined. Okay, and now we can find g composed of f of x. So now whenever we see x, it's 1 over x, we'll plug in f. So 1 over the absolute value of x minus 2 minus 3. So that's the most simplified we can make it, but to find the domain, we have to work with the absolute value. So what we're going to do is we're going to take the absolute value of this, and we're going to split it into positive and negative, so we can find out what it equals what x equals when the whole equation equals 0. So if we do positive, everything in the absolute value will keep its sign. So we're going to do x minus 2, and then you don't change what's outside of the absolute value. So minus 3 equals 0, because we want to see what it's going to be when the equation equals 0. So x minus 5 equals 0. So x equals 5. So that's for the positive, and now we'll do the negative. So we change the sign of everything inside the absolute value. So it becomes negative x plus 2 minus 3 equals 0. So that is negative x minus 1 equals 0. And if we move the x over, it becomes positive x. So negative 1 equals x. So now we know when x is 5 and when x is negative 1, the denominator will equal 0. So now we can write for our domain that x cannot equal 5 or negative